Welcome to the project discussion week. In this week, we are going to take a look at what are the requirements of the final project and in what format is the submissions required, right? And in order to start getting you thinking about your final project, I'm going to walk through some of the ideas. Some ideas are taken from the Python project for data engineering. So I'll walk through some of their lab and give you some tips for how you can extend them for your data engineering project. Let's get started. The final exam for data engineering for AI consists of two components, a written component for 40 marks, and this being a hands-on module, there will be an individual project for 60 marks. So the individual project is again broken into 15 marks for your mid-course project review, where you have to suggest what you are going to achieve by the final project, and the final project submission for 45 marks. So the submission requirement for your final project would be a 10-minute presentation to the whole class or a subset of the class, and all your codes needs to be submitted via GitHub. So the mid-course project review will happen during the second course review week, review week. So let's take a look at what are the requirements of the project. You are expected to use all the functionality that you have learned during this course. So typically, you have to look at it from a ETL perspective. So we have talked about data models, we have talked about ETL tools, and subsequently we are going to talk about data processing tools. So your project needs to load data from some transactional database or some file system into a data warehouse. You can choose whether you want to load into a cloud data warehouse, or you can create a local data warehouse, right, using your Postgres database. Some sort of processing needs to happen after you store your raw data or en route during the ETL process. And eventually, you will also have to show me some analytics query on what kind of queries can be run on the database that you have created, on the data warehouse that you have created. I'm going to use some of the projects from the Python project for data engineering module in Coursera. So there are 3 labs in that course. One is an extract, transform, load ETL lab. Second is a web scraping lab. And the third is a extract data using API lab. This gives us a fundamental idea on what could be some of the sources that you can look to. In each of these explanation, I'll also give you how you can extend these projects for your final project. Okay, so please don't use exactly these projects for submission. This is only a first step to give you idea. Right, submission of just these projects will not be accepted for the final project. Before we talk about each of the lab, a very quick review of the ETL process, the extract, transform, and load. In order to extract, you need to first identify the data source that needs to be extracted. So this can be a file, different set of files coming from different sources. It could be an API, right? We'll see examples of that. So you need to extract data from your transactional database or your operational database, transform it, make some changes, probably ensure that all of the dates are aligned, all of these transformations can be done, and then you have to get it ready in a format that is ready to be loaded into your data warehouse. So in some of the examples, we'll see the load stops with just creating a file of the transform data. Typically, I would like to get you to load it into your data warehouse because we have looked at all the skills required for that. Right? So this is the typical workflow that you will see. So let's dig into the ETL lab of the Python project for data engineering. So there data is from 3 different sources. There are a bunch of .csv file, bunch of .json file, and a bunch of .xml file. So there are extract code written for each of these file system. Right? So the extract from CSV is to read data from a CSV file, extract from JSON to read from JSON file, and then you extract from XML. So this typically is using the XML library, ET, to parse the XML, right? So depending on what data source it is, you will have to write the corresponding extract function. All right. So then you move on to doing the transformation. In this example, what is happening is all of the data source have similar data, which means there is a name and the height and weight of the person. Right. So this is the data that is formatted into CSV, JSON and XML. So it's fairly easy to sort of append them all into a particular data frame. But typically your data sources don't come with the same exact schema, right? So you'll have to transform them in some way to bring it to the same schema in some cases, if that is what is of relevance to you. And then you can do additional transformation. In this case, effort has been taken to convert the inches of height into meters by using the conversion formula. Similarly, the weight in pounds have been converted into kilograms. So that is the transformation that is being done. And finally, as I mentioned earlier, the transform part is essentially the loading part of it. So they save the transform data in a ready to load format, which is a .csv file. So here, of course, as data engineers, we already know how we can connect to the database and load it into your Postgres RDBMS, right? So you can typically load it into your Postgres as well.
Walkthrough of the extract transform load lab. Here you see that there is a function to log. This is a very important part of any ETL process. So we have seen that in our Airflow as well, right? Logging. So here it's done explicitly in Python, other than the extract transform load code that we saw. So I'm going to just show you how the process gets running. So I've run the first part of the code. So we log the ETL process started, which means the log file is showing ETL process started, right? And then it is going to say the extract phase started, extract phase ended. If all things work fine, combining the three source CSVs, three source JSON and three source XML, you should have a total of 39 records, right? So then we are essentially transforming. So after you transform, you get your name, height, and weight, right? Which is now being loaded into your transform the target file, which is transform underscore data.csv. So this is a very simple example, but I wanted to point out a couple of things that will happen when you are trying to run your ETL process, right? So here, if you look at it, the extract format is looking for all the CSV files in a folder, all the JSON file. So at the end of this run, what has happened is we have created a transform underscore data in the same folder, right? So if you run this file again, your transform underscore data is also going to get added, written, right? So you have to think about, so when you're reading data from a file, how do we ensure, like, has the data been read and put into the transform data? So you want to either delete the file, right? So that subsequently newer files can get come in. So always think about what are all the challenges in doing it in a scheduled manner on a day-to-day basis, right? So this is to just give you the very first structure for the ETL process, but it's important for you to think that what are all the things that could go wrong with such a system, right? So go ahead and try out this exercise. So this is essentially trying it out on the car dealership data, so that you can learn to extract from different data sources. So if you are extracting from different data sources, it's important to know that you'll have to have different logic to extract the data sources. In this case, the CSV, JSON, and XML have very, very similar formats, but that may not be the case in other things, right? So you need to know what is the format, the schema of the original files that you're bringing in, so that you can only extract the relevant subset of the data for your process.
There are several extensions that you can think of for the ETL lab, right? The ETL lab is pretty basic because it just brings up data of multiple formats. The idea is how you deal with extracting data that belongs to multiple format. So think of a particular use case where such a process needs to be done, right? So it could be probably attendance that comes from different classes, probably doing it in different styles. If each instructor is doing attendance in a different format, etc., right? You need to merge it all together. It could be sales that comes from manual sales versus automated checkout at a particular counter, etc., right? So you can think of, so that helps you to think of how do we extend this project. So one ideal extension would be you load your transform data into your data warehouse, right? And another way, since we have learned the ETL process using Airflow, so can you write your extract, transform, and load as a DAG file, right? That can be scheduled and run every day, right? And instead of the file folder, you can think of reading your data from a web URL. So let's say those processes, whatever the processes are, the sales process, etc., who is submitting different names, are submitting to a particular Google Sheet or S3 storage, right? So you're reading data from a specific web URL every time. So, and then you can decide after you transform it, do you want to delete the original data because it's already read, or do you want to keep it? Because this is makes a very important thing on because every time you are going to look at all the CSVs in the file, in the folder, then every time this data will get added on to your transform data as well, right? So how do you deal with that, right? So think of how to schedule this ETL job. If you want to, if it is running on a day-to-day basis, right? What are some of the challenges? So think of these while you are thinking of your project ideas. So the ETL lab is just a framework for you to get to start thinking. It is not a project in and of itself. It's too simple to be a project. So try it out. Try out the extension work that has been given so that you'll get idea as you try it out. The second lab is about web scraping. So in this case, we are scraping some information from Wikipedia. So you can think of this process as just the very first step of the ETL process, where you are reading data and converting it into one of the data source. So your web scraping can be created as a data source, or the other way to look at it is how it can be interpreted as an ETL process in and of itself, right? So you're reading data from the source, you're making a request to the URL, and then you're extracting the information. So Python has this very useful library called Beautiful Soup, which helps you to format information, right? So you can format HTML text and make it, so since your HTML has a certain format, so you can take a HTML table and convert it into a pandas data frame. Right, so it's essentially the name of the bank and the market cap. So then we are doing some transformation. So essentially this is not transformation, this is essentially reading the HTML file, right? So if you think of the data as a HTML file, then you are extracting and transforming it into the structured format. Or you can think of it, as I said earlier, you can think of doing all of this as just the first step and then combining with other data sources. Okay, so this will also give you some ideas on how you can include web scraping as also one of your data sources. But you will have to, web scraping is not easy. You will have to make sure you know how HTML needs to be parsed. And then, so in this example, you can see that you're going through the T-body structure, right? And the TD and TRs in order to extract each of the information from each of the row of the Wikipedia text.
Lab, we are going to essentially web scrape from a Wikipedia page, right? So the packages that are used are Beautiful Soup and the request package, which essentially help us to web scrape. So let's take a quick look at the Wikipedia page. So this is the list of all the large banks, right? So let's say you want to find out the assets and try to benchmark where a particular bank is with respect to the rest of the bank. So Wikipedia gives you your HTML file. So one way to look at it is you right click and look at your page source, right? So you can look at this whole this thing. So probably I will show you instead of page source, you can do an inspect. That way you can see, you can highlight uh, some segment of your this thing so that you can see the corresponding HTML page here, right? So this is what we are trying to do by looking by through code when you are doing web scraping, right? We are reading the HTML which gets returned back when we make a request, right? So here we are making a request. So 200 is success. So what gets returned, we are putting it into the beautiful soup object. Beautiful soup helps us to parse the HTML very easily. So in a HTML, there are very important tags, right? So you have the HTML, the document object model, right? So you have your, typically it starts with your body, and then each here it is your table body, then your table row. TR stands for table row, TD is your table division, all of that, right? So from there we are essentially finding all the T body and looking at the second. So technically your the entire soup object is going to be, so if you look at it, this is the entire HTML page that comes out. Of that, what soup object helps us to do is to parse the HTML by looking at each of these specific HTML tags, right? So we are going to look at we are essentially going to look for this table, right? So I will close this for now so that this comes back. So we were going to look for this table. What is the HTML that helps us to create this table? Right, so that is what this extract is doing. You're creating a data frame, and then if you look at it, we are looking at a T body tag, and then find all the TRs. So find all gives you the set of all tags, set of all table rows, and from there we are extracting the information corresponding to the title, and the market cap is not as a particular attribute, right? So for this, you should know a little bit of HTML of how you parse your page, right? So you're getting a neat table. So this you can write it into CSV. That will become a source for your data, right? So you can then combine it with other data sources, etc. One of the things to keep in mind is when you're doing web scraping, do make sure if there are any violation or any rule that has put in the website in terms of scraping data. Typically, you want to do web scraping in a in a page where the structure is very well formed, right? And then you can fuse it with other structured data. So this could be the data that you scrape from the web can also be a way, can also be a data source for your project. So think about it.
Some ways to extend on the web scraping lab. So typically you want to do web scraping in a page where it's the HTML is fairly structured, right? For example, I've done a lot of web scraping on Craigslist to use to look for price information. It could be used car price or rental information, etc. Right. So another thing is you can think of web scraping as a source to bring in data which you can extract, right, along with another structured data source. So let's say, for example, if you're bringing a movie rating data set in CSV format from Kaggle or any such data repository, then you can go to Wikipedia to get the corresponding plot of the film or the lead actor or the day, the year of release, etc. Some other information which is not available in your movie rating data set, right? All this you can actually extract because Wikipedia is fairly structured. So here these are lines in which you can think about for your final project. So to summarize, we got introduced to the requirements of the final project. Please do remember that both the written exam and the final project are mandatory components in your in order for you to pass this course. Then we discussed some of the ideas from the Python project for data engineering course as well. So we looked at the ETL lab and how do we do web scraping. So in the next video, we'll talk about something called the API. How do we get data from APIs? Thank you.